So maybe now let's talk about serverless.
Yes, absolutely.
So it means a lot of things to a lot of people, and people get confused about what exactly it means. Does it mean lambdas? Does it mean
but
no
there's still servers?
Still servers, right? Yeah, that's the thing. You have serverless, you have servers. Can you give us an introduction of what you think of serverless and what serverless is?
Yeah, of course. So on the on-site, I think the reason we talk about serverless is not that there are no servers anymore, right? Like obviously, as at Netlify, we run a lot of servers, so I should know, right? Like, and Amazon runs lots and lots of real hardware servers underneath it all, and so does Google and Azure and so on, right? But the thing is that with the idea is that developers stop using servers as part of their abstraction layer, right? Like before serverless, as a developer, we sort of had to think about our server, right? Like when we wrote code, like what server is it running on, and where is it executing? And the idea of serverless is that level, like that the level of abstraction sort of moves up a level where we just write the code, and then it runs, and there's no, like, in the process of writing and even operating that code, we're not working at the abstraction layer of individual servers at all. Right?
So basically, you don't think like I should put something on the hard drive of the server.
No.
You might not find it.
You don't think it like that, right? And to make that sort of viable, one of the things that had to happen was this idea of just a function as a piece of code that could run somewhere, right? Whereas before, again, we built applications that would run on a server, right? And now developers are starting to be able to think for some of the problems they solve just in terms of serverless functions, where they say, okay, I write a function that reacts to some event, often maybe an HTTP request where it sends a response, and that function is just going to run somewhere. And I don't really care where, I just care that it actually runs, and that it runs every time someone wants it to run.
Maybe anywhere.
Maybe anywhere, right? Like that also means that we can start thinking more about distributing these functions. I think some people tend to conflate a little and think that as soon as you have serverless functions, they might be running anywhere. Whereas in reality, a lot of the time where people use serverless functions, they still talk to some kind of data store. So it depends, right? Like sometimes you might have very pure serverless functions that just does some computation, but it's actually rare that like if you have a serverless function that just does a computation, you'll probably just do it in the browser or something like that, right? Or wherever else you're running code, right? So most of the time when you actually build a serverless function, it's because you want to interact with some API or some persistence layer. So in terms of distributing these serverless functions, it then becomes like more of a question of where is your API and your data layer distributed.
Or where you want it to be distributed.
Or where do you want it to be distributed?
So basically, if you have an app that is global, you can choose to have your function running as close as possible to that client that is requesting.
Precisely. That's sort of the ideal world, right? Where you have like a globally distributed persistence layer and globally distributed functions. In reality, most people still have centralized data
stores, and
because there's a lot of like challenges around consistency and so on once you start distributing your data. So I still think it's pretty normal to see a world where, in our case, like people will distribute the front end globally and they will have everything running there, but the individual serverless functions they'll want running next to their API and next to their data store, because otherwise the like maybe the function will make several calls to the data store in one execution, right? And if you distributed the function to the edge, that would actually make the end result much slower.
Yeah, because there are way more exchanges, they talking a lot, the function.
Precisely.
And data, they talking a lot.
Precisely.
And each time you add delay, each time they talk to each other, right?
Yeah. So
you don't want to have that too far apart.
So right now I actually still think that for most people, they actually care a bit more about like the functions being centralized but close to their data store but I think what's changed is that often that data store is something they no longer have to think about scaling. Either it's a managed database or it's just an API, right? Like it's like Stripe or whatever.
But still, you care about where that API is.
But still, you care about where that API is, right? Then I do think that in the future, as the whole ecosystem evolve, of course, since this abstraction of serverless functions allows you to say, like, we could quite easily now just check a set of regions and have them running in a lot of different places. We might start seeing more distributed data stores behind those, right? Like, and we're seeing it in some cases, right? Like, FaunaDB is an interesting like collaborator. We've done some cool stuff with. They've built like an add-on to Netlify, so you can one-click provision at FaunaDB, right? And FaunaDB is one of those databases that's just inherently like.
There's something that we did back in actually since the beginning of Prismic.
Yeah.
And we wrote our own database,
yeah.
which is something not to do.
Absolutely.
I advise anyone not to do that. But we still operate it, and actually works well because for our API. So we're thinking like okay. Content is so crucial to a website.
Absolutely.
If content is not there, the website is not there. That's it.
Yeah.
So we thought, how can we make the content API, the delivery API, extremely scalable, like and very available, like and it had to be in the architecture. So what we did actually is that anytime someone publishes something, we do an an extraction. Like we get a piece of that, like let's say like the layer of the database, and we get it away and we put it on S3. So it's a file system. So it means that you can get that API. Like let's say up anywhere you want in the world, because and now what we're doing is that we're having a function, a Lambda function that will download that extraction of the API for a certain client and can read and talk because there's no write operation coming there. It's only read.
It's only
so
read.
It's push notifications and it can be loaded everywhere, which makes it available for people any way they want, right? And that combines very well with this kind of notion of serverless.
Absolutely,
right?
yeah.
Because
That's
you
really
can
cool.
distribute it. You can have several instances in the same time running, no problem.
And you don't have to that's another thing that people discovered when we're sort of still in the sort of shifting phase and people start using serverless function with a more traditional database, that the traditional database is more used to like, okay, you have a certain number of clients using it, but suddenly you're telling this like your cloud provider, just give me as many functions as is needed, right? Like if all these people come at the same time, then just give each of them a function and they'll talk to my database, and suddenly you start like running out of connections to your database and so on, right? So
and all the sharding is not good because it talks about each time you add a server, you should redo the sharding, which is a huge operation. It needs to be distributed.
It needs to be distributed
by design.
So in that way, I think we'll see a lot of these tools. Like that's why people are talking about serverless databases, which
that's
again,
what we have. I guess we should talk more about serverless databases.
So you should talk more about like a serverless content database. Like,
exactly. So that is distributed that way. And
really
actually what we thought about at some point, like we might even give that copy to someone to host it, whatever it's a small file. Actually, it's Lucene behind the scene.
So
they can download the files and have their API on their side.
That's really interesting.
What did you call it? Serverless.
Serverless content database.
That will become a thing, right?
Yeah.
And also, when you talk about serverless, so basically, we talked about the fact that, but there are some things in the architecture that you need to be aware of when you develop for serverless, right? As a developer, what other things?
What other things?
You need to be careful about when you do this kind of architecture.
Yeah, I mean, every single architecture we've ever come up with has trade-offs, right? And there's never any specific silver bullet, right? So I also think realistically we'll still see a lot of hybrids where serverless functions right now will be used really often for specific things and to solve like a set of problems that's well geared to where we are right now in that architecture. And then you will still want to build like long-running microservices for other things where you sort of control, okay, this has this amount of instances running where systems like Kubernetes, that's sort of what what they provide, right? And what we'll see more, like Kubernetes is still like fairly painful to work with and operate. So we'll probably see more abstractions in terms of like how do you run those kind of long running services without having to, as a developer, having to understand the full abstraction of Kubernetes. And then serverless functions will be really handy for all of these like immediate event responders, right? Where it's very clearly like, okay, you can put it into a clear abstraction where you get an event, you do something, and you return something, right?
Simple. It's like simple operations, let's say.
Yeah. We see them, like what we see a lot in people building with Netlify.
Yeah, that's interesting. What do they build with it? Yeah.
We see a lot of people building. So we see a lot of people building either like generated sites or single page applications that talks to different APIs and so on. But really often you just need that, like you need a relatively simple server-side endpoint just because you need the secrets, right? Like that's probably one of the really big use cases. It's just that even if you use Stripe for all of your payment flow, you still need some server side code. You can't put your Stripe secret in the client side, right? Like, don't do it for sure, right? Like, but if you have 5 lines of server-side code, you can build a full e-commerce today, completely client side, right? You just need those like 5 lines to actually talk to Stripe and confirm an order, right? Like Stripe even gives you like the client side checkout widgets and
everything,
elements and everything. But you need that 5 lines, right? And that's one of the things that feels so powerful that before serverless functions, just for those 5 lines of code, you needed to start thinking about infrastructure and having a server somewhere, right? And running a server, right? So we do see a lot of use cases of relatively small surface area functions with a simple functionality. We use them as ourselves in our infrastructure for a couple of cases like that, for communicating with GitHub, for things like that. We use them in our infrastructure for screenshots. So that's another use case where the scaling part is the strength, right? Like if you have some fairly like some tasks that could take time and that would be a pain to scale in a traditional server infrastructure, right? Like in our case, whenever you publish a new deploy, we spin up a headless Chrome and take a screenshot of that deploy, right? And again, it's one of those things that when you have people publishing millions of deploys all the time, right? It starts being pretty annoying having to like scale clusters of headless Chromes across different servers and so on. But again, with serverless functions, we can just like
take advantage of the fact that it's already implemented all the
all of the scalability, like all of the like sort of auto scaling without having to think about it, right? So you just write a function that takes a URL and gives you back a screenshot, and now problem solved, right? Like that when things fit into those kind of problem domains, the magic of simply being able to not having to care at all about like operations, scalability, anything like that is very powerful.
Right. So for instance, if I want, like some people would like, okay, they do a function, okay, for serverless.
Yeah.
But then should I have in that like several endpoints in that kind of, or each endpoint should be a serverless function?
So I honestly think
should it be fine-grained? Or?
I think the difference is not as... people are obsessing a lot about that difference. Should I have a function for each endpoint or different ones? And I think what will really end up determining that is the developer experience around each of the 2 approaches, I think. I think right now, each approach has trade-offs, right? Like if you... the more endpoints you have, the more potential cold starts you'll have, right? Because each endpoint will like...
cold start.
With serverless functions, one of the gotchas is the cold start.
Can you explain a bit what cold start is?
So the cold start is that the way these all of these providers of serverless functions work is that they don't actually create an instance running your function before someone requests it, right? So your code is uploaded to an object store somewhere, and then the moment someone requests an execution of that function, the provider will spin up some sort of very lightweight virtual machine. On Amazon, it'll happen with Firecracker, And in a very short time, they'll be able to fetch that code from an object store and spin up in it a virtual machine and reply to the request, right? But every time they have to spin up a new instance of a function, of course, there is a little wait time between the request and actually having the function available. Then they keep that function around. Like in Amazon, they'll keep it around for like 20 minutes or something like that. As long as it.
But is it about like that delay? Is it about running the code, or is it more about provisioning and networks and stuff like that?
I don't have like the deep insight into what Amazon exactly are doing, right? But my guess is that they'll need to actually fetch the code from an object store and have a scheduler pick a free instance in all of their clusters and deciding like where should it spin it up, and then have Firecracker spin up the container itself, which is very fast. But then your function might also depend on, like, if your function is based on Node and you have a bunch of Node modules, right? Like just triggering the initial like server start or whatever like is there,
it takes time.
Actually takes some time, right? Because you need to load those Node modules from file and get your function running, right?
Is it a good advice to tell, like, you need, if you have less dependencies, it will be quicker, maybe?
If your function can start quicker, it can start quicker, right? Like that's fundamentally it, right? Like and probably if you have very few dependencies, it'll start quicker, right? So again, you could say that could make the cold start quicker if you have many very small functions, right? But my experience is like from building any system, like I've seen some people talk about the joys of going back to sort of the days of PHP, and it's something that someone actually built a lot of web projects in the days of PHP that doesn't specifically like resonate, because I felt that there's a pretty good reason we moved sort of away from the idea of every single PHP file being its own thing to, even in the PHP framework, sort of having a centralized router, because you start realizing that all of those functions often need a lot of the same dependencies. They all need to do the same authentication. They all need to do all of your base setup for instrumentation, for all of these things, right?
So you can't break them into little pieces. If they share
the little pieces tend to end up sharing a lot of stuff, in my experience, right? Like just from what I've seen so that's why I'm saying, like, I think it will be more of the developer experience behind like what's actually the most convenient to work with as a developer. And I think it's quite early. People are really experimenting a lot with that. Like people like this, the people doing the architect framework, the people doing like Next and Nuxt and so on, are all thinking about this in different ways. There's a lot of people just running existing Express servers in functions.
Maybe part of the problem could be that, okay, if you're, and I've seen a debate on that on Twitter. Like if you're developing in some kind of development environment where things are local, and suddenly you tell, okay, can you split it up and make it distributed? You might not be aware of the latencies that will be added, and that will be a nightmare suddenly, right? And you go the other way around. You say, like, let's start directly developing in that kind of mode, so you have no surprises. Am I right?
Well, I mostly just think like let's. I think in this case, people are thinking a lot about, like, should we have more in each function or less in each function, as if it was the infrastructure that would be the constraint we should really think about there. And I think the difference there is actually, like, there's an equal amount of trade-offs for each, right? Like if you have a slightly larger function, well, it can handle more of the requests, so you get less cold starts. If you have more smaller functions, each of them might start a little faster, but each of them will have more cold starts because they
have less calls.
Because they have less calls, right? So it's probably not that part of it that's the most important right now. The important thing is actually to figure out, like, how, as a developer, is it most convenient for us to write our function? Is it easier for us to split them up into a lot of small endpoints and reason about that? Or is it easier for us to have, like, a set of functions that each have a set of routes, and we have our little router for each of them? Like, and I think that's, as a provider, I think I have to support both use cases.
At least in the transition period until we get
and
a
then
clearer
we have
picture.
to work a lot with the different frameworks, and we have like on our end we have Netlify Dev, where we try to make sure that people get the best possible sort of local development experience around like.
But does it replicate the latency of
it doesn't replicate
production?
the latency so far. No.
Yeah, okay.
No.
So they should think about, okay, what will be the latency whenever I will be deploying it?
Yeah.
Right.
Yeah.
And do you the problem? So I was.
But it's an interesting point. I mean, wouldn't it be hard for us to simulate latency if we wanted?
That could be something you can ask. So I was thinking also like. So the problem, there's one problem when you're going from zero traffic to some traffic, because that you get the cold start. But if you look at Amazon Lambdas, the problem is that when you get from even 10 to 100, another older order of magnitude of traffic, again you will get in the cold starts,
some new cold
which are maybe avoidable in that case, because you already have some functioning functions that you can just let them function, and in the background spawn other lambdas whenever they're ready. Now you can maybe start pointing traffic.
It has to do with how so one of the things that's interesting, as far as I can see from digging into sort of the custom runtimes of AWS Lambda and writing a couple of those, is that the concurrency model is essentially like one function per concurrent user, right? Like. So in that way, they do have to just scale to the number of concurrent requests that are there, right?
But the problem, like if you get a request, like imagine you have 10 and you have 100 requests. Maybe letting these requests wait is better than giving them to a function that's going to cold start, because cold start might take 1 second, whereas waiting might be like 100 milliseconds, which is much better than when giving it to a function.
But there I would kind of trust Amazon to just implement the right queuing mechanisms for optimal performance over time, right? Like that's a nice thing with sort of delegating this to these cloud providers, that they're in a good position to simply measure and just.
Well, I guess they're not there yet. Maybe there's. I mean, there have been a lot of news about the fact that they're working on it. So probably they will get there at some point.
Yeah, I think that part will just keep getting like. All of that part will only keep getting faster, right? Like, and only like cold starts will only keep getting smaller until we reach. Like, I'm sure there's some theoretical limits for how fast they can get them ready, right? You probably also get options for prepaying for some number of running functions. Like Azure already lets you do that, though it feels more like
server
now you're
full.
back to server full, right? Like now I actually have to take decisions about like how many servers do I want to run, which is like back to, oh wait, wasn't that what I was supposed to not think about, right?
You find yourself in that kind of discussion.
The other interesting thing we see is that when people build with sort of the Jamstack approach and mostly use the function for the API layer, the cold start tends to be much less important, right? Because really often that layer gets invoked only when there's like
afterwards
a real action happening, right? Like if you think about an e-commerce checkout flow or something like that, like you might invoke a function once you click order, but at that point it's not actually that important to conversion rates or anything, whether it takes like 100 milliseconds extra, whereas in the point where you're actually showing the product
the
pages,
website,
those 100 milliseconds are really
count.
what, especially over multiple like hour flow where you're navigating a site and going through a checkout and so on. Like if that's slow, people will just lose their attention span is short and they'll go somewhere else, right? But once you've clicked order, like a few extra, like 100 milliseconds extra is not what's gonna stop. Like they're not gonna like cancel like immediately.
I'm not a UX expert, but I'm going to buy into that.
Yeah.
Okay. Well, thank you very much, and maybe next video we talk about the new things that you announced for Netlify or you're working on.
Yeah, sure.
Cool. Thanks.